Hello. Good morning, everyone. It's great to see you all here at Ignite. Welcome to the session on driving efficiency and cost optimization for Azure's IaaS deployments. I'm Rajeesh Ramachandran from the Azure Compute team, and I'm joined by Sam from Morgan Stanley and Yuemin Lu from Azure Storage. Today, we will show you how Azure helps you to maximize your cloud investments through smarter infrastructure choice and real-world customer success. Let's dive in and explore how Azure empowers you to get the most value from your cloud infrastructure choices. Across industries, IT leaders are focused on maximizing the value of their cloud investments. But doing more with less comes with its own set of challenges. We consistently have heard from customers about unpredictable cost, over-provisioning, missed savings opportunities, and operational complexities that comes with scaling infrastructure. For compute, it's about selecting the right VMs, leveraging savings instruments, and automating scales. For storage, it's about right-sizing, choosing optimal tiers, and automating lifecycle management. And for networking, it's about achieving resiliency and scale while maintaining financial efficiency. We hear these challenges loud and clear, and today we will show you what's new across Azure IaaS to help you control spend, boost efficiency, and most importantly, innovate with confidence. Every architectural choice impacts cost and performance, whether it is build versus buy decision, technology selection, licensing cost, billing models, or operational overheads. Maximizing cloud value isn't just about spending less, it's about spending smart. Some workloads needs premium performance. Others can be optimized for efficiency. As your business evolves, your cost posture must also evolve. Today, we will break down Azure IaaS, compute, storage, and networking, and walk you through how to design, build, and optimize each for the best price performance and lowest TCO. Let me kick off with compute, the foundation of every Azure's deployment. Azure has been rapidly expanding and modernizing the virtual machine portfolio, with new generations rolling out across every category. And we are excited about what new SKUs offers today, like better price performance for every day's workload, stronger built-in security and reliability. Whether you're running enterprise apps, cloud-native services, high-performance computing, or next-generation AI workloads, Azure now gives you an even wider range of options, each designed to deliver the right mix of capability, security, and cost efficiency for your specific workload needs. Since last fall, Azure has expanded the general purpose and memory-optimized VM families with new V6 generations powered by 3 leading CPUs, Azure Cobalt 100, AMD 4th Gen 𝗵𝗫𝗫𝗫𝗫𝗫𝗫𝗫, and Intel's 5th Gen Xeon. These V6 generations deliver significant improvement in compute, memory, storage, and networking, with at least 10% boost in price performance over previous generations. And trust us, we are not stopping there. Looking ahead, we are continuing to evolve the portfolio with our next wave of innovation, our new AMD and Intel V7 now in preview. These new versions bring new performance. These new versions actually bring even more performance, headroom, scalability, and flexibility. When it comes to cloud cost optimization, one of the easiest and highest impactful decision is simply choosing the right VM. Azure gives you a wide range of price performance options so you can match your workload to the right SKU. Newer families like the DA, EA, and DP series can allow and get you better price performance up to 40% compared to older generations. When we align the VM to what the workload actually needs, you lower cost and gain efficiency by design. Now let's look at something brand new, the VM vCore customization capability, now in public preview. The feature gives you price control over how compute is allocated inside your VM. You can disable SMT to get full physical core performance or use configurable constraint cores to choose fewer vCPUs while keeping the full memory and I/O. This is particularly helpful for database and analytics workload, with per core licensing, letting you to use the VM you want while paying only for the cores you need. The result, lower licensing cost, better single-threaded performance, and fine-tuning efficiency without changing your VM size. Feel free to scan the QR code to learn more about it today, and also to sign up for the preview. When you're thinking about optimizing cloud spend, Azure gives you 4 flexible pricing models: pay-as-you-go, reserved instances, savings plan, and spot. Pay-as-you-go is great for spiky and unpredictable workloads. Reserved instance give you up to 70% savings for steady and always-on workload. Savings plan offers similar discount with more flexibility by committing to an hourly spend instead of a specific VM. Spot delivers the deepest discount, up to 90%. Well, a quick show of hands, how many of you use Spot today? Oh, that's great. If you're not using it yet, yes, by the end of the session, I'm sure you will be trying it one. All right, let's dive deeper into Spot virtual machines. So what is Spot? Spot VM is Azure spare capacity. When we have the capacity, we give it to you, and we reclaim it at 30-second notification when Azure needs the capacity back. Customers love Spot because it isn't about cheaper. It is about running more than 5 to 10x times your workload at the same cost. Spot pricing follows demand and supply chain, so it stays relatively stable. You request capacity. When it is available, we will give it to you. And more flexibility for you is offered across using multiple VM sizes, families, and regions that will allow you to expand your capacity per options on Spot and also unlock your savings. We are excited to announce the general availability of Spot Placement Score. It predicts how likely your Spot VM request is to succeed before you deploy by analyzing real-time capacity signals and historical trends. Each configuration gets you a score that shows where Spot capacity is most available and stable. Higher score means higher placement success and lower interruptions. Instead of guessing, you can deploy Spot with data, improving reliability and maximizing savings with lower risk. Now let's look at a quick demo of this feature.
In this video, I will demonstrate the Spot Placement Score feature on the Azure portal. Select Virtual Machine Scale Sets, then click Create New Virtual Machine Scale Set. Fill out the desired VMSS configurations under the Basics tab, then click on Spot. In the Save Money with Spot section, select Turn on Spot. Azure portal will automatically generate a high, medium, or low placement score based on the configurations listed in the Basics tab. To update the configuration, select Edit Configuration and modify the size, location, availability zone, or desired instance count. Let's say I want to use zones 1, 2, and 3 and deploy a total of 20 VMs across these 3 zones. Click on Generate New Score to obtain a new placement score. Since the score is high across all 3 zones, the configuration has a high likelihood of being fulfilled. To save this configuration, select Save and Apply. The configurations have now been saved under the Basics tab. You can now continue to update and create the VMSS.
So that's Spot Placement Score, helping you predict Spot availability before you deploy. Now let's talk about Azure Compute Fleet, our newest GA service available in all public regions. Compute Fleet makes it easy to launch a mix of Spot and on-demand instances with a simple fire and forget model that automatically optimizes for cost and capacity. You can combine Spot, reserved instances, savings plan, and pay-as-you-go pricing models in a single fleet request for superior price performance. You may mix up to 15 different sizes, VM families and regions for greater scale, and choose Spot allocation strategies that prioritizes for capacity, lowest price, or both. In short, Compute Fleet delivers flexible, automated, and intelligent optimization to get you the best blend of cost, performance, and scale for any workload. With that, I would like to invite Sam to talk to you more. Yeah, thank you, Sam.
Grab the clicker. Okay. That's fine. Sorry, technical. Hi, good morning. My name is Sam Shteingart. I work at Morgan Stanley. And I'm running the group responsible for maintaining and managing infrastructure for high-performance compute, or we call it HPC, in a public cloud. Let me first take a moment and explain to you what is HPC and why is it such a good match to run in the public cloud. So HPC is a suite of applications which calculate VAR, or value at risk, which is basically a statistical measure which estimate potential loss to the firm or to a specific portfolio. Morgan Stanley is a bank, and we are required by regulation to submit various compliance reports to various regulators on a periodic basis. Some of them have to be submitted every day, some every week, every month, every quarter, annual, etc. HPC applications calculate several billions, with a B, data points every day. In order to perform all those calculations, we need a lot of compute capacity. On top of it, some of the reports we have relatively short period of time to calculate. We cannot start the calculation until market closes in a particular region, and sometimes we have to submit it the same day. So we have a few hours to crank a lot of data. So as you can see, HPC is a very good match to run a public cloud because we need a lot of compute capacity and we have relatively short period of time when we're going to use this capacity. Typically, HPC applications look the following way. The jobs is broken into many individual tasks, thousands. Okay, each task is quite finite. It gets some input, does calculation, generate output, sends the output to aggregator. Each task runs between seconds to minutes. The jobs, which is a combination of those thousands of tasks, runs from several hours to several days, depending what we're generating. In order to do this, typical application, we would like to provide as much compute capacity as we need as quickly as possible and run the application. When the application is completed, deallocate this capacity as quickly as possible again because we don't want to pay for it. Okay, with this brief introduction, now we're ready to talk about the stuff that, we really came to hear from me is how we control the cost for all of this, okay? So, number one, the vast majority of spot compute, of HPC compute runs on spot. Okay, we use hundreds of thousands vCPU cores every day, and to use on demand, even for a few hours a day, would be prohibitively expensive for us. Now, in order to run on spot, we have to modify our applications. Number one, applications have to be able to handle spot evictions. So the schedule have to realize that particular VM was evicted. The task that running with that VM has to be resubmitted somewhere else. The next question we need to answer is, okay, so what VM families do we want to include in the manifest for this spot? Okay, as Rajesh mentioned, you specify a number of different VM families to decide from where to get your spot capacity. So we can decide, we need to decide, do we want to use less expensive general purpose D families? Do we need more expensive compute optimized F family? Do we need more expensive E family, memory optimized, etc.? But keep in mind, this is spot. So even more expensive families will probably cost you significantly less than on demand. And if they have a good high availability, spot availability, that may be a good choice for you to go with. The next decision is where do we want to run the job? Which region? The spot price changes from region to differs from region to region, and it also changes over time. So we keep a close eye on where is less expensive and periodically move our jobs. So compute generate vast majority of the cost for HPC plant, but network and storage could also add up. So for network, the answers are relatively straightforward. Minimize the amount of cross-AZ traffic and minimize the amount of data that you want to move back on-prem. For instance, the application generates app logs. Do we really need to move those logs back on premises? Okay, or is it okay to keep in the cloud and only move it when we need it, or actually analyze them directly in the cloud? Storage is a little bit more interesting. For storage, again, we have to set up, number one, storage retention policy. You know, how long do you keep something in the cloud? And what do you need to keep in the cloud? And also, what type of storage do you want to use? So recently, Morgan Stanley switched from using managed disk from SSD v1 to SSD v2. In the process, we got better performance because of better IaaS performance and slightly lower cost. Also, you look at your specific application and decide, okay, the application using database, do I need to keep the entire database content in the cloud, or is it okay to cache 10%, which I really need, okay, and reduce cost of storage significantly this way, potentially impacting performance slightly. Okay, so I mentioned several ways oh yeah, one more thing, profiles your application. We're using 100,000 cores every day. If you're not optimizing your, utilizing your VMs appropriately, you're basically throwing money out of the window. Even slight improvement in utilization of the particular VMs will result in dramatic, significant saving over time. So I mentioned several ways how we can save money. Which one should we focus on first? Okay, and that's where Power BI comes in to help. It helps us to see where we're spending money, okay, and decide what to focus on. For instance, should we move application from one region to another? Should we move the particular application from using AMD CPU to Intel CPU or vice versa because it's performing better based on our data, okay? Should we remove particularly expensive VM from the catalog for particular application because that application has soft SLAs, doesn't have to be finished in particular, you know, really quickly. So if it experiences a few evictions, we're probably okay. Okay, how long should we keep certain logs, etc., etc. So this is actually real screenshots which we took from data which I accumulated over the last during the year. The top chart shows the cost of spot compute in different regions, 3 different regions which Morgan Stanley uses for our production HPC application. As you can see on the chart, until April the cost was about the same, so no decision to be made. Then starting in April, the cost in East US2 increased significantly compared to 2 other regions. So guess where we're running applications now. The second chart shows normalized cost of virtual CPUs for different CPUs families. Some of them considerably more expensive, so maybe we want to avoid using them, maybe not. Remember, they may be more expensive, but they have fewer spot evictions, okay? So we would like to keep those if we have tight SLAs. So again, decisions have to be made on application by application case. And this is another screenshot. This is a screenshot of CycleCloud, which is Microsoft tool for managing an HPC application in public cloud. So what you see on this chart is the following. This is one of those end-of-day reporting applications. This we ran a couple of weeks ago, so it's a real, okay, and a little bit sanitized. The job began to run around 7 p.m., finished around 10 p.m. It scaled from 0 to 80,000 cores in 10 minutes, which is pretty amazing. At the peak, the application was running at 90,000 cores, which happened to be our spot quota in this particular subscription and run application. It is important to set reasonable quotas, okay? If you have runaway HPC application because somebody introduced a bug, you can spend a lot of money. Been there, done that, so, okay. The black drop-down box shows that we're using about 20 different VM families to run this application. And the log underneath the graph basically shows that there was a number of spot evictions, but application handled it rather gracefully. So in summary, Morgan Stanley runs multiple HPC applications in public cloud. We run it in multiple CSPs. We run multiple regions in CSPs. We use cross regions and cross CSP failover strategy, BCP strategy, and we exercise it on a regular basis. We peak at about 2 million spot cores every day, and we would not be able to afford to run HPC in a public cloud without carefully managing the cost and constantly optimizing and modernizing our HPC plan. Thank you, and we'll move on.
So thanks a lot, Sam, for sharing a real-life example on how you can leverage Spot VMs. I'm going to move forward and talk about storage. So let's start with giving you a quick refresh of what is the latest offering we have on the truck, so that as you're looking into building your new applications, you always have the latest and greatest in mind for cost optimization. Starting with UltraDisks. With the relaunch of UltraDisk, we are able to bring down both the cost and also the scalability up on the specific offerings, and then provide you best-in-class business continuity support. So for the relaunch of UltraDisks, given this is a cost efficiency session, we wanted to get into some numbers. So this is an example which we built based on an actual example of one of the financial services, not Morgan Stanley, but other financial services we work with. So with this specific example, as you can see that with the new provisioning model on the cost for the GB, we are able to reduce 6% by allowing you to provision exactly on the GB increment without needing to pay to the next closer tiers. Then on the IOPS, we are extending both the minimum and the maximum IOPS you can support on a specific size. So in this case, if your application needs moderate IOPS but extremely low latency, you can provision 5,000 IOPS exactly as what you wanted. By provisioning the IOPS exactly as your target, this alone can give you 62% saving compared to before on provisioning IOPS. And last, on the bandwidth, we are lowering the minimum bandwidth you're able to set on your disk with a fixed specific Mbps instead of one which is scaling on the size. So that if you have a deployment that has a specific Mbps limit, you will be able to set it exactly where it is. So with this specific example, you'll be able to provide a 22% reduction on your total cost of saving on your UltraDisk. Wow, you may say that, okay, my application doesn't need UltraDisk performance, which is in extremely low millisecond. From my workload perspective, it's more like a general purpose business application. So what will be the right disk size for you? This is where we introduced Premium SSD V2, which is the new generation of V1. So with a like-to-like setup, Premium SSD V2 will be able to give you roughly 30% cost reduction on V2. I know that many of you have not yet adopted V2, maybe because of some capabilities you depended on V1. So we totally understand on this, and we have been making a lot of investments on this area. As you can see in this year, we released support across live resize, Azure Migrate support, Azure Site Recovery support on V2, and also instance access support, so that you'll be able to move to Premium V2 to gain the cost saving while continue to use some of the capabilities that you depend on with the previous series. Well, besides disks, we have a new member in the block storage family, which is Elastic-SAN. So when is Elastic-SAN a good fit versus a disk? In this case, Elastic-SAN is where we expect you to deliver. You will use Elastic-SAN when you have a large storage pool of block storage. This is for scenarios like you're hosting services on behalf of your customers. For example, you have multiple SQL databases instances for customers of different districts. Or you have scenarios where you yourself as a SaaS providers, where you have multi-tenancy services, where you wanted to pack customers' deployments of different tenancy into one storage pool. This is where Elastic-SAN comes very handy, as it provides you the cost efficiency at scale. So how do we do that? This is where we leverage on the ability to dynamically share your performance target across multiple volumes. So in this specific example, let's say you need 10 terabyte disks for different database instances. And in individual disk, your peak traffic can go to 80,000 IOPS. In normal cases, you will be provisioning 80,000 IOPS in individual disks, where in total you end up provisioning 800,000 IOPS. However, as you are monitoring the traffic across these volumes, the aggregate of all of them stays steadily below 500,000. With Elasticsearch, you can provision exactly as 500,000 IOPS and dynamically share this total IOPS across all the volumes. This comes in very well for scenarios where you are lifting and shifting your SAN appliances from on-premises to cloud, where you can focus on sizing on the entire appliance rather than trying to get every individual volumes to the right size. Another scenario where Elasticsearch comes very handy is on VMware migration to Azure VMware solution. So in the on-premises world, most of you probably uses SAN appliances, which sits along with your virtualization environment to scale storage independently of your compute. While on cloud, Azure is the only cloud that provides you the capability to scale your storage independent of your managed VMware solution. In this example, Elasticsearch is able to give you close to 3 million savings over 3 years for a storage-intensive deployment. I know that some of you may have looked at Elasticsearch and run into situations related to private endpoint cost. This is one of the things we are working on as well for the AVS scenarios. We're exploring support for service endpoint so that you'll be able to use other mechanisms to connect to Elasticsearch. All right, I'll move to file storage. Our investments on file storage for cost optimization have a very consistent theme. This is to allow you to independently provision your performance targets and your capacity needs. This applies for the provisioning model for both Azure NetApp Files and also Azure Files. Starting with Azure NetApp Files, we introduced flexible service level, which allows you to provision your size and your throughput independently. This alone gives you 30 to 80% savings compared to previous ANF SKUs. There are a lot of other capabilities we offer on ANF that helps you for your cost savings for different scenarios. I will pick one, which is the short-term clone. This works very well if you have an environment that you need to do a lot of DevOps testing. So using clone, you'll be able to quickly replicate your ANF shares without needing to do a full replication and pay for the entire copy. All right, what about files? Files, we support provisioned V2 model. Yesterday, I was talking to someone on the counter. They was like, oh, I saw this experience on Portal, so how could I use it? So Files provision V2 model allows you to set your IOPS, bandwidth, and GB independently, where it operates just like current files. We support it on both standard and premium file share. If you're using Azure File Sync to set up a hybrid environment with your on-premises Windows file server, you'll be able to get additional cost savings in your daily sync on the transaction cost by this new provision model. All right. We now wanted to talk about how you will be able to monitor and manage your costs on cloud after you have built and deployed. There are two key challenges or pain points we hear from you. One is that, oh, I always need to over-provision for my capacity because my application grow. I don't want it to get to a situation where I don't have space for my additional storage. So with that, our attempt is to introduce auto-scaling capabilities. So we started with Elasticsearch. This is where we provide you the capability to set a policy on your SAN based on a threshold that you can set on your usage. So when your actual volume storage usage exceeds this threshold, you can add increments towards that. And this is fully automated by our platform. So you don't need to end up keep monitoring how much you're using your storage and then always need to scale in demand ahead of time. We will take care of it for you with auto-scaling capability. Well, when I move to, from block storage to object storage, the challenge becomes a different aspects, which is, okay, object storage, I give you multiple different tiers, hot, cool, cold, and archive. But how do I ensure that I always have my storage on the right tier in response of the change of my dynamic workload pattern? I'm very excited to announce the public preview of smart tiering for Azure Blob Storage. This is a fully managed automated data tiering solution that removes you the guesswork of which tier I should put my data in. Let me show you smart tiering in this demo.
Smart Tier is configured at the account level. We are using the Azure portal to create a new storage account with Smart Tier as a default tier. Smart Tier is available today for zonal redundancies. I am therefore changing the redundancy for this new account to ZRS, and on the next tab, we can then select Smart as the default for all objects. So we don't need to worry anymore about manual tier placement across the hot, cool, and cold access tiers. I am uploading a few datasets with mixed access patterns that infer the selected default tier, and from now on these objects will be monitored and inactive objects that will be tiered down fully automatically. Let us switch to an existing storage account now, so we can leverage these new capabilities for existing data. This storage account's default access tier is currently set to Hot Tier. I have many datasets with different access patterns hosted on this account. Most of the datasets are using the default account tier Hot inferred. Other objects are explicitly tiered to Hot Tier. By switching the default tier setting to Smart for this account, all objects that are not explicitly tiered will automatically be moved to Smart Tier and are monitored in the same way as new objects would be. We are not billing tier change transactions for moving objects into Smart Tier. There is no need to enable any additional tooling or policies to leverage automatic cost savings. Smart Tier will keep regularly accessed objects always on the hot capacity tier and starts down tiering inactive objects after 30 days to the cool tier capacity tier and after an additional 60 days to the cold capacity tier. Once you access the object through a read or write operation, the object will immediately be tiered back to the hot tier. The rehydration is instant. This initial operation will already be billed against the hot tier. This means you're getting the best of both worlds. The automatic down-tiering of inactive data paired with the billing model simplifications of Smart Tier can lead to drastic cost savings over time, making it the ideal access tier for many scenarios where you can either not fully anticipate access patterns or don't want to explicitly manage tier transitions. In the metrics view of the storage account, we can see the distribution across the capacity tiers for smart-tiered objects for both object count and capacity. As we can see in this example, most of our objects are not being accessed regularly, and after being stored on the hot capacity tier initially, most of them are being moved to the cool and cold tier over time, drastically reducing the capacity charges for those objects without any manual intervention.
I can see this being a very much wanted feature, which is good to know. Yes. So while we have smart tiering to get the right tier on individual blob, what about your account, storage account? What about across your storage account? How do you manage your storage footprint? This is where Azure Storage Discoveries comes in very handy. You can leverage Azure Storage Discovery to uncover insights across your storage account and present you via Copilot on opportunities for further optimization. It is very smart. You can use Copilot to ask questions like, okay, for all my hot accounts, which ones has the lowest transaction? And based on that, you can decide whether you wanted to lower it to cool tier. And you can use storage action to move them in batches to move them to cool tier. So it comes very handy. Try out Azure Storage Discovery today, and you can explore new opportunities that will help you optimize the cost. All right, last but not the least, we wanted to spotlight a few best practices you could consider to optimize your networking cost. We have categorized our recent release and new announcements into 3 key buckets. First, how do you achieve higher scale on ExpressRoute with better price performance? Then, how do I build better resiliency at the same or even lower cost? Last, reduce the cost of monitoring on networking services. All right. Starting with ExpressRoute, we are introducing the public preview of ExpressRoute's Scalable Gateway. This SKU allows you to scale your virtual network gateways dynamically. You can scale up to 40 gigabits per second. On the Scalable Gateway, you can set 2 configurations. One, auto-scaling, where you define a min and a max. Within this, Azure will automatically scale the settings based on your real-time bandwidth and flow demand. This is a huge improvement in terms of operational efficiency and performance. You can also choose fixed scale unit if you know what is the traffic pattern and if it's very predictable. In both cases, ExpressRoute Scalable Gateway will allow you to actually set your schedule gateway in a way that responds to your traffic while paying for the bandwidth that you need. All right, if you're looking to scale up your ER further for scenarios like AI training or massive multi-site deployments, we are debuting the native support of 400 gigabits per second express routes very soon. This will enable you to unlock 4 times increase on the scale at only 3 times the cost. The cost saving is not just from paying for the ER. By using ExpressRoute circuits that has higher scale on the individual circuits, you reduce the overall circuits needs and also reduce on-premises CapEx you needed on routers. So the saving just combines. Well, besides on the scale, which is one dimension that may increase your cost on ER, the other factor is resiliency. You often need to plan for multiple ER circuits that helps you to plan for the redundancy. Today, we're introducing ExpressRoute Metro that helps you to provide better resiliency at the same or even lower cost. Let me roll the demo.
Hello. I'd like to take a few minutes to talk about optimizations for what is often one of the more investment-heavy components in your network, ExpressRoute. ExpressRoute connects your on-premises environment to Azure using private connectivity, either direct fiber or a service provider's network, bypassing the public internet. In the Azure well-architected framework, we introduced resiliency tiers for ExpressRoute, standard, high, and maximum. These tiers are based on the peering locations, connected to your ExpressRoute gateway, which lives in an Azure region. But the circuit itself resides in a co-location facility, a network hub outside Azure's data centers. These facilities are robust and redundant, but they can, on rare occasions, go down. Let's look at peering location resiliency. For example, in Atlanta, we have Atlanta, Atlanta 2, and Atlanta Metro. Atlanta and Atlanta 2 are separate buildings, typically within 20 miles to keep latency low. Metro means Microsoft has ExpressRoute links into both, and we've worked with providers to enable connectivity across them. In Amsterdam, Amsterdam 1 is Equinix AM5, and Amsterdam 2 is Digital Realty AMS8. Choosing Amsterdam Metro gives you a link into both facilities. You'll see this visually in the Azure portal when creating a circuit. Now, maximum resiliency means 2 standard circuits in 2 separate peering locations, like Washington, D.C. 1 and D.C. 2. This offers top-tier uptime and latency, even during maintenance, and comes with a 99.95% SLA. To help support this level of resiliency, Microsoft offers a discount on the second circuit. But there's also a more cost-effective option, high resiliency. This uses a single circuit with links into 2 peering locations, like Washington, D.C. Metro, a single circuit, but you still get site diversity. The SLA here is 99.9%, and the cost is about 25% lower than maximum resiliency, the same cost as a single non-site redundant ExpressRoute circuit. Microsoft sees this as a strong balance between mitigating single location failure risks and maintaining cost control.
All right, so on the resiliency aspects, we're also announcing the public preview of Zone Redundant Net Gateway. So Net Gateway allows you to connect your private VNet out to the internet via an assigned public IP. So today, actually previously, before a public preview, to achieve the zonal resiliency, you need to deploy 3 network gateways, 1 in each zone, to protect against zonal failure. Now, with the Zone Redundant Net Gateway, you can just deploy 1 single gateway, and that will give you the resiliency across the 3 zones at a cost of 1 gateway. So this is where you could see that you you will be able to deliver like only the same level of resiliency at only 1/3 of the cost that you have today. All right. The third category of cost optimization lands on monitoring. How would you monitor your network services with minimum cost? Primarily, the cost comes from storing the logs. We are having new log filtering capabilities for 2 network services, Network Watcher and Azure Firewall. So Azure Network Watcher allows you to collect VNet flow logs. It captures all the packet header information and store it for your analysis. With these new filtering capabilities, you can capture the ones which you're interested. For example, using filter based on IP, action, or ports, and more. This simpler log management significantly reduces the GB cost you need to pay to store your logs. And if you add this with the smart tiering capabilities, you could even tier your logs which you're not accessing so that you can get more cost savings. By filtering, it not only saves you cost, it also saves your time. Now you have a much limited number of logs you need to examine for further troubleshooting or diagnostics. This is one of the very popular asks we hear from you all. Well, we're doing the same for Azure Firewall. So for Azure Firewalls, we also added filtering support on it so that it could do the filtering and shaping of your logs before ingestion. So you can pre-optimize your storage cost and reduce the raw data for an analysis. Once you have these logs stored, you could consume it by the Policy Analytics, Security Copilot, and Microsoft Sentinel. We use these AI assistant solutions to help you accelerate your troubleshooting. Now I have come to the end of this session. I hope by hearing from us, you get 1 or 2 tips that could help you optimize your cloud spending. Thanks, everyone.